Hello everybody, Chris here, and in this part 2 video I want to continue working on our player for our 1-bit projectile platformer. So the player script that I set up before, it extends from platformer character 2D, and it has that direction property which we're using to control the X velocity or the left-right movement of our character. So I kind of want to pull some of this out. When we're getting the input, we can, of course, keep it inside of our player script, but we could also make it a separate component like we did with the facing script. So the more functions we put inside of a single script, basically the harder it becomes to reuse that same script across different objects. So we might have, for instance, different types of players that behave a little bit differently, but they might, for instance, receive input all the same way. So let's go ahead and pull our player input out to a new script, and then we'll have the input target a player character 2D, the player, for controlling the velocity here still. So I'm going to right click on player and add a child node. So this one will just be a basic node because it doesn't really need any 2D position or transform elements. So let's create that. I'm going to rename this to be player input, and then let's attach a new script to it. So right click, attach script, player input, and we can save that into player, create that. So I'll go ahead and give this the class name player input. And then inside of the player script, I'm going to grab this direction equals, and we're just going to pull that out to the player input script. So function, we could keep this on physics process for now. So we'll say the direction is equal to the input line that we got before, the actions. So the actions, we probably also want to put them in this script rather than the base player script. So I'm going to pull out export var actions, and then I'm going to paste that line in here. Okay, so where are we setting the direction? We're setting that on the platformer character 2D. So we need reference to export var, we'll say character, of a platformer character 2D. And then character.direction is equal to this because the direction property is set on the platformer character. So we're going to change the direction from within our player input script, but the actual direction, at least for now, rests inside of our player script or platformer character 2D script. Now, why would I make it reference platformer character 2D rather than the player script, which extends platformer character 2D? That's just because the platformer character 2D base class has all of the necessary properties for the player input to run. So we don't need to specify it any further. And this would allow other types of characters to theoretically be used by this player input class. So when you make your class type more generic, it would allow more types of objects to actually be used here within the script. So let's assign to the player input our export properties. The character is, of course, the player. And then the actions, we already created that. I'm going to load this from the project with quick load, and we have our player input actions. So we put that in there. And if we click on the player script, you can see that the player input actions is no longer needed there. So we're not concerned with the input actions or the player input inside of our player script anymore. We're only moving the character body based on its directional input and its move speed. And that's basically all that's going on in the player script. So if I hit play now, it's going to work exactly the same way. I can still move left and right. The facing script is controlling the left movement, and the facing script is controlling whether the animated sprite faces the left and the right. Can also, once again, be used for other nodes if we put any collision shapes down there, like a hitbox over here, if you want to flip that to the left or the right, depending on which direction the character is facing. But yeah, we're just kind of starting to take our character and separate it into different smaller scripts that all work together to generate the final behavior of the character. So I just thought that it would be a good idea to get that out of the way now before we start adding a bunch of extra script logic to our player and we end up with a very bulky player script. So now that we've done that, we can also add an action to our player input actions for jump and then work on the gravity affecting our character. So inside of player input, I'm just going to click on the script to open that up. We want to add to player input actions the jump action. So I'll right click here and look up symbol. So that jumps us into the player input actions class. And we can do @export var jump, which will be a string name. I'll use tab to get over to the same spot as the other colons, and then string name, and we'll default this to jump. while we're at it, since this is going to be a projectile-based platformer, we're obviously going to have some kind of shoot action. So let's at export var shoot tab colon string name, and I will just call this shoot as well. So that'll be there for later, and we can go to project settings, input map, and we can define those. So it looks like I actually forgot to assign S as the down key. So let's do that now. Add input, press S to automatically select the S key. Okay. And let's also add in those other actions, jump and shoot. So jump, shoot. So for jump, we could make that, let's say, spacebar. So just add a key, press the key you want it to be, or the button on your joystick. And then shoot, add event, and we'll do left mouse button press, okay, and close that. So next up, let's go back to player input. Where we have physics process and we're getting the direction, I think I actually want to change that to process so that we can get this direction possibly more than one time per physics frame update. So physics process usually runs at a set number of times per second, but in that fraction of a second, we might actually change our input. So we could probably improve this a little bit by doing _process and then getting the vector here. So having the input be got on a process frame instead of a physics process frame just means that potentially we can update that 1, 2, or 3 times, maybe more, per physics frame update, depending on how often the physics frames are actually updating. So it'll basically take the most recent input, and when we get to the physics frame, it'll update with that. And I think that might make the character feel a little bit more responsive than having the direction be gotten on a physics frame. So that's what we'll go with for now. And just keep in mind that when you have code executing on the process function, it's going to be updating on every single frame of the game. So it can be kind of resource intensive, but for this, it should be perfectly fine, just to be aware. So now we also have other key presses that we need to watch out for. So we can handle those in, let's say, unhandled input. Unhandled input meaning if nothing else in our scene consumes the input first, then we'll execute the code in unhandled input, as opposed to function input, which I believe will execute that no matter what. So if some UI is consuming the input, we don't want the jump key to actually execute or the shoot key to execute. So that's why I'm doing unhandled input instead of _input for the function. Okay, so when you have unhandled input, you get an event, and this event may have an input action associated with it, like these string names up here. So if we check if the event action is the jump action, then we can execute a jump or execute a shoot action for our character. So let's do a if event.isActionPressed, and we're going to check for actions.jump. So if jump is pressed, then we want the character to jump. So for the actual movement of the jump, I think that makes sense to have on the platformer character. So now we could say character.jump and just run that function, which currently doesn't exist. So at this point, you might actually decide to take the character and change this from platformer character 2D to player. The reason for that is that maybe not every platformer character can actually jump. Maybe a lot of them can only move left and right. So if that's the case, then you may want to just take this and change it to player. Now, that's not really going to cause you issues because in player import, we've already assigned this as a player. So you see, even when we change the class name, it doesn't unload this property or anything like that because the player was already a player character 2D. And now we're just being more specific and saying it needs to be a player because this character needs to be able to jump. But maybe we change the property name to be more reflective of that. So if you want to rename the property and every instance of the property in the script, just fix everything at once, you can double click on the text you're trying to update, hit Control-R on your keyboard, and then replace it with what you want. So we want to call it player. So player. Now to be careful about this, there might be cases where you have like a comment and player would match there. So you may want to check match case so that only the lowercase instances of this text. And if you want to be more specific, whole words, just making sure that you don't like rename comments or anything like that unless that's your intent. So we have these three instances selected. If you see the gray box around them, we can replace all, hit Control S, and now we do need to reassign the property because the property name changed. So just assign that to player, and we're all good. So I know I'm changing the code around quite a bit to update it as we go, but hopefully you can see that like as your requirements change, you can use some of these tricks in order to update your scripts very fast and not really run into too many issues as you are kind of updating your game prototype. So we require player to have a jump now. If I was to go hit play and we press the jump key, which is spacebar, it's going to give us an error because jump does not exist on the player script. So we can go into the player script now. Okay, so now in the player script, we're going to create the jump function. So function jump, notice no underscore because this is a public function, so calling from other classes. We don't probably need a return type, so we don't have any need for this. Unless we wanted to say that it was like successful or not, then we could return a Boolean. And this will say, makes the character jump if possible. So we might want to decide for our character, what are the conditions where our character would be able to jump? So first off, a basic character would be able to jump on the ground. You can add double jumping for your platformer character, where you can do like an air jump. That's super common. So inside of our player script, let's first check if the character is on the ground, and then we can do a ground jump if that's the case. So let's see, if self dot, let's see, ground or is grounded. So let's start by checking if the character is on the ground, and if it is, then we'll allow a jump. So if is on floor is a function that you can get out of CharacterBody2D. Now we can check if is on floor or is on floor only. So if you wanted to prevent the character from being able to jump when it's also on the wall or also on the ceiling, then you could check this instead. For now, we'll just do is on floor. So if the character is on floor, then I guess we'll execute the jump. I'll go down here and create another function called jump. And I'm going to make this a underscore for private. But here, I'm going to rename this one to be try jump. And let's return a Boolean whether the jump was successful or failed. I said I probably wouldn't need to do it, but when I think about it, I think this makes more sense. So if is on floor, then we're going to jump. And after we jump, we'll return true for a successful jump. If we get down here because the character wasn't on floor, then we'll return false for a failed jump. And let's go down here and add a comment. Returns true if jump successful, or false if failed. And then the jump itself will be modifying the y velocity. So velocity.y plus equals, let's say a jump force, because this is going to be instant and it'll decline over time due to gravity. So let's add a export range up here. At export range, let's say 0 to 100, 0.2 or greater. We can modify that later if we need. Var jump force, which of course is a float, and I really don't know how much we need, so we'll say 100 to start. And of course in the inspector you can modify it as you need. We won't allow negative jumps because that's kind of weird. If you really needed to have the character jump upside down, you'd probably flip the character upside down with like scale Y and then add the jump, which would make it propel in the negative direction, negative Y direction. But yeah, that might be all we need there for right now. So let's jump into player input, and we're going to call, instead of .jump, we'll do try jump. So we're requesting a jump from the player, but it's actually the player script itself with its try jump function that's going to determine if the jump executes or if the air jump executes. And we'll return true or false whether the jump or air jump executes, just as basically an informative piece for any other scripts that need to know about it. And we could give a comment down here, execute a ground jump. For the air jump, we might have an air jump force that's different than that. So later, I guess I'll create a function air jump, which will add the air jump force instead of the jump force. You could also rename this ground jump force if you want to be really specific. Okay, so let's hit play, and I'll hit space, and we'll see what's going on. So when I hit space, nothing really happens. So what we want to check in player input, so what we're going to want to do is set a breakpoint here to see if player.jump actually executes. So let's hit play and spacebar, and we can see that it does hit here. So why is our character not actually going up? Well, if we jump to the player script, we can, let's say, add a breakpoint here and hit continue or F12. And we see it's not actually going there. So our character's not on the floor probably. Let's set a breakpoint there. I'll hit space and let's check our character and see if he is on the floor, if that property actually shows here. Okay, and I'm not seeing that being publicly showing. So let's stop that for a second. And what I'll do is I'll create a variable is on floor. And this will be equal to the result from is on floor. And then we'll use that over here because this is a Boolean. If you not required, it's pretty obvious, but you can type this if you want. And now when we hit play and hit spacebar, we'll be able to see that local variable is on floor. Is this on floor true or not? And we can see is on floor is actually false, which is odd because our character does appear to be on the floor. So we need to figure out what's going wrong. So let's actually take our player and hit W, move him up here and play and see, okay, gravity isn't affecting the character either. And that's probably a big part of why it's not showing on the floor. So we can always check the error log and see if there's anything weird going on here. None of these warnings should really be causing an issue, but we can go ahead and clear them up right now. So if we double click here, we can see that this delta is never being used in physics process. So if we want to eliminate that error, just give it an underscore and indicate it's never used. If we click here for the is on floor, well, this has the same name as the function. So we might want to rename that. Or really, I think in most cases, we could just take this and put it back there and just use the function call instead of having the variable. We already kind of checked that it wasn't on the floor, so we don't really need that variable there right now. This is already clear enough. If it's false, then it's not going to jump. And if it is true, then it will jump. And then we have that third one over here in player input. Can add an underscore delta. Just make sure if you are trying to fix this never used property thing, that if you ever do use it again, you just remove the delta because now it is expected to be used by this function. Okay, so that'll eliminate all of our warnings for now. Okay, so if I recall, what we actually need to do in our player script is to add the gravity in. So the CharacterBody2D by default doesn't have gravity added to it. If we check project settings, and we search for gravity, we can see that there are settings here, which we can use and pull from to add the gravity to our character. So on physics process, after getting our left-right import, we do want to update our character with the gravity. So we'll say velocity.y plus equals, and let's say get gravity, which is a function we can use, but we're going to times that by the delta, which is the time between physics frames, so that the character moves at a consistent amount, and that's based on the amount of time that has actually occurred. So times delta. Now you might see that we put the underscore there just a second ago because we weren't using the delta. Now I want to get rid of that. Okay, so we can see that a vector can't be automatically applied by a delta float in Godot, but we can easily work with that. So let's actually create a function here, apply gravity, and then we'll take this bit in here and pull it down to the bottom, apply gravity, and I'm going to paste that in. We're actually going to make this underscore for private as well. I can't imagine a reason why another script would be needing to say this, because the player is going to manage its own movement, basically. And then we have velocity y, and we're going to plus equals the y gravity. So a vector 2 is going to have an x and y. So let's say var gravity equals, they get gravity here. Okay, so we're only calling get gravity once, and then we take gravity, paste that down there, times y, times delta, which we need to actually pass in. So delta float. Okay, now for the function, that means we need to pass in the delta up here. So apply gravity, delta. So we pass in the delta, and then we get the gravity for our character. And then we're going to plus equals the y gravity times the delta onto the y velocity. Now, if we check project settings, you can see that it is actually possible to do a x vector for the gravity. So you could, in theory, have gravity going to the left or the right. Maybe certain game levels are kind of like that. So what we can do is say velocity.x plus equals gravity x times delta as well. just in case the x gravity is in fact not 0. So with that, we can hit play, and we can see that our character is actually falling, which is kind of what we want. So before we fix the falling through the ground issue, I want to take apply gravity and move it up a level to the platformer character 2D script, so that any platformer character 2D has the option of applying the gravity to itself, as most characters would, but all characters should really have that option. So let's cut this function with Control X, go to platformer character 2D, right click, lookup symbol, and just paste it in there. So now if we have an enemy, our enemy can also call apply gravity in its process or physics process functions, just like the player can. And if we go back here and Control S, we should be able to resolve the issue where apply gravity doesn't exist, because it's now coming from platformer character 2D as a parent class. Okay, so why is our character falling through the floor? Pretty simple. The reason is that our tile map has no physics collision shape. So that's very easily fixable. If we click on our tile map layer, and we have tileset expanded here, so we can go to tileset at the bottom, open that window, and we can edit our tileset. Then we want to paint on physics layers, but we haven't added a physics layer to this tileset yet. So expand physics layers, add a physics layer. We'll just leave layer 1 as our ground. So if we want to name that, which is a good idea, click here and edit layer names. So we'll call layer 1 ground. So anytime we want to collide with the ground, we reference layer 1 in the collision mask for, let's say, our player or any other objects, possibly arrows or anything. And now that we've done that, we can go to paint, select a property, select physics layer, and let's click on these tiles. So left click, left click, left click, or you can press and hold and just add the physics shape to all of those. Now, we can see that it might be a little unfair at the corners for this to actually be collision worthy. So if you want to adjust that, you can add more points on the collision shape here, so to speak. So I'll press left click there to add one and left click there to add one, and then pull this inwards. So now these corners shouldn't cause collision. Also, you might want to pull this in 1 pixel and 1 pixel. You can zoom in if you need to. I think there's also a snap to pixel option, so we might want to toggle grid snap, and make that, let's just say 1 pixel. And we probably want to do half pixel snap. We'll kind of just adjust these points to get the shape we want. And up there, only the solid grass, not like these individual pop out pieces, are going to block out collision. So that's a bit more involved and a little tedious if you do that to all the squares, but it might be worth it. So I'll click here to assign what we just adjusted to there. Now you can also rotate and flip these with R, E, H, and V. So if I press R to rotate, I can left click there and assign the new collision shape there. R to rotate, R to rotate. Okay, there's the 4 corners. And now we can kind of do something similar with these. So let's reset to default tile. Press there, left click, and just pull these down a little bit at the top to there, and on the right side to there. So that's going to give us that 1 pixel buffer. Now we can click there, so it's consistent with our side pieces. R to rotate, click, R to rotate, click, R to rotate, click. And now we've created a good collision shape for all of these pieces. And if we go to the top window, we can do debug, visible collision shapes, and that'll show the collision shapes when we hit play. So let's hit play. And there we can see the collision shapes of our ground. If we hit spacebar now, it's still not jumping, but at least we're hitting the ground. And we can also see the collision shapes apply up there at the top. And we have like a little bit of a curve here on the sides. Depending on the game, you might or might not want that, because you can see that kind of lets you kind of curve around the edge. So it's up to you if you want it to be like a pure classic box, or you want that kind of curvy collision shape. Okay, so why is our character not jumping? Let's figure that out. In our player script where we have try jump, let's do a print, and I'm going to print is on floor. So this is for debug. Obviously we're calling is on floor twice, but this is just to get a console of the true false value. So let's hit play and let's hit space. We can see that, oh, our character is actually on the floor, which probably means this is executing. So if I hit space, okay, we come here, we add the jump force. Yeah, so now that I think about it, in Godot, I believe down is positive and up is negative for the y value. So we actually want minus equals the jump force. Let's run the game again. I remove the breakpoint. We hit space, and there's our jump. So that's my bad. You subtract the jump force to go up. So negative values to come up here, positive values to go down. And our jump isn't very high. So we might want to click on our player and increase the jump force. Let's say 300. And this is the instance of the player, not the original player. So you can see in the original player scene, it's still 100. But out here in level, it's 300. So be aware of that. We're changing the copy of it inside of this scene, not the original values. So if we come in here, we hit space, and there's our jump. Our character doesn't move very fast, so we might also want to increase the move speed to like 120. And there we have like much better movement. Now our character can't quite get up here yet, so we could either add in a double jump, or we can increase the jump force. So I'll increase the jump force for right now. Let's hit play. Okay, maybe that's a little too much. Let's make it 350. You can also change these values during gameplay. You don't have to actually stop for that to happen. But we have basic gravity and jumping working there. Now, if you like those values and you want those to kind of be the defaults for your game, you can go into the player script and just change these and update them here. So 120.0, and then whenever you have a new instance of the script, these will be the default values. So jump force 350.0. If you save it, then we should see that they kind of reset there. If they haven't, then it's probably because the value is different in the player scene, not the instance, but the original saved one. So if we reset that in there, it should reset to the script default. Okay, now any copy of the player should move basically like this. And that's pretty much it. So to show one more thing, when our character is not on the ground, if I hit spacebar a bunch of times, you'll see that it's false because is on ground, it is false. So that kind of confirms that our is on floor check is working. We can remove that. So for now, our character can only do a ground jump. But I think we'll leave it there for this video, and we'll work on animations and possibly double jumps, adding in the shooting functions and all of that stuff in the upcoming videos. So thanks for watching to the end. I'll have the snapshots of the course for this part 2 video in the Ko-Fi and Patreon links down below. And hopefully I'll see all of you guys in part 3.